Okay, you probably hear me. Hello, everybody. It's a big pleasure for me to be here because it wasn't that obvious. Yesterday, my plane was late 5 hours, and they were suggesting that I should take the morning one. I didn't take my chances because it wouldn't be that obvious to be here. So, let's start. My name is Artur Skowroński. I'm the head of Java Kotlin development in the Virtus Lab. This is Polish software house, Polish company. Important information on the beginning. Everybody knows the drill, that we have Slido. You can have questions there. And I hope there will be some, at least at the very end. My company is, like I said, software house. However, we are also involved in open source. Anybody still using Scala in this room? Oh my God, one person? That doesn't look good. However, like I said, we are involved in the open source, especially in the GraalVM space, particularly in the Scala ecosystem, because we are current steward of Scala. And I don't know what it means for us seeing you all there without Scala usages. However, like I said, this Scala department, I'm in Java 1. So most of the time, my responsibility is discussing with clients and new projects. And I'm not telling you that to sell you anything. Fortunately, with the role, there's perk of having people to do exactly that, so I don't need to. However, very often I have discussion when some popular buzzwords are appearing. And one of them is cloud native. And you know what? Whoever is using that term has always something different in mind. So I started to wonder, maybe I will not create any compressible, some new definition that will be used by everybody. However, I will have at least my own. So I started to dig about what did it truly mean for Java to be cloud native. And the result is that presentation. It will be helicopter view. Because you probably have seen already in the title that there will be GraalVM, and we already have multiple presentations about the GraalVM today that were going very deep level. Mine will cover GraalVM in the 5 minutes. However, each of the topics I will touch today will be put in the context of the whole ecosystem. So I will try not go very deep, however broad, and put all the puzzles in the proper places. There's one digression here. This presentation is like a cat. It fills all the necessary space, so available space. So I have 50 minutes. I will try to fill them properly because there's 100 slides. 50 minutes, so I gotta go fast. So if there will be any questions, please leave them at the end. And most importantly, no memes during the presentation is here to offend anyone. It's just my standard way of communicating. If anything, I kindly ask you to understand, especially to people in Oracle. Okay, so now let's go and start the proper presentation. What you see here is what I found out when I started to put term cloud native Java in the search in Amazon. And what you see here is there are multiple books like that. Cloud native Java, modernized enterprise Java to cloud native, pro cloud native, etc., etc. And this is just tip of the iceberg. So probably we should ask ourselves the question, is Java truly cloud native? And my answer is, it's getting to be, however, for not that long time. And probably right now, a lot of people will start throw tomatoes for me, but I don't see you have any. Because why is that? Every new code that we are currently reading in the Java language, it's put in the cloud. It's most of it, at least. There is the cloud repatriation trend. However, it's probably on the edge at the moment. However, so we are mostly put our Java code, it's deployed to the cloud. And here comes probably the main keyword. This code is deployed. And as we have seen at the original Dilbert comics, it's not exactly the same. Because most of the time, and I know you are not doing that, but I promise you, your friends are doing exactly that. We are just creating Java application, putting them in the jar, then in the Docker, or to bare metal and call it a day. It's not that easy, at least in my opinion. That's why I would like to make a bit wider picture how it looks like and how it what the whole ecosystem looks like now. And the presentation will be split into two parts. The first one will be about framework and standards. The other part will be about runtime. Okay, framework standards. That's probably the first part we will cover off. Because what you have seen there, that multiple of those books that I have already presented, our bookshelf, it is mentioning Jakarta or Java EE, or at least Quarkus. And I have a question. How many of you is using Jakarta or Java EE? Yeah, close to Scala. Funny. Yeah, and fact is that for years, Jakarta or Java, it's quite hard to discuss about it, especially in the historical context, get a bit of bad raps. And what I would like to show you today, that those standards are quite fine and worth exploring. But to explain why this was problem with Jakarta in the past and why that bad reputation of the whole ecosystem, let's discuss its history. Because Java EE started in the 1999 when our servers looks like that. Is the original scan server. I was looking in Google just to find that picture. So that is original Jakarta EE server. And after years, it was created for enterprises who decided it's good time to enter the web space. And if enterprises, so main clients of Java wanted to do that, the standard happened. Simplification, like I said, a lot of simplification during that presentation, but it's probably the background of the whole ecosystem. And you know, after the original Java EE is right now called the full profile. And full profile was developed. It has a lot of stuff that is not necessary today because, like I said, we are talking about the servers that looks like that. So there was a lot of mainframe specific, maybe not mainframe specific, but some server specific stuff that was used in that context. So at the time, the people responsible for Java EE decided that they need to modernize the whole platform, make it fit well to the modern web standard. And they did it. And they created so-called web profile. But you probably see the date there, 2009. Modern web standards in 2009 don't look like modern web standards in 2023. So to make an analogy, this is full profile, so original spec of the Jakarta, or of Java EE. And probably that's how people today are seeing the web profile. So monolith, but smaller. So after the years, there was less and less traction to the Java EE platform. Oracle itself also lost a bit of the interest, unfortunately, so decided to just share the standard with the community. And it was taken by the Eclipse Foundation. Eclipse Foundation decided, okay, we will rename it to Jakarta EE because trademark. And if that would be only change of the name, that probably wouldn't be any problem. However, there is one part of the specification that have trademark as well, and needed to be changed because the original agreement with Oracle, and I don't want to say anything that is wrong there, however, that's my understanding of the topic and what I consulted, was that the Java space needs to be renamed because Java is a trademark of Oracle. So no code under that package could be changed until it was replaced with something different. So it took a few years and few Jakarta EE version. Meanwhile, microprofile was presented because finally Jakarta achieved what they wanted. So it was in the Jakarta 9.1 in last year. It was finally fully migrated, which resulted with a lot of different dependencies, like for example Spring, Hibernate, things like that. They are currently not backward compatible because they decided to switch to the new namespace. But meanwhile, as community didn't want to wait for Oracle and for Jakarta to publish something new, microprofile standard was developed. And microprofile, as you see, or you don't see because there's not very big contrast, was quite clever idea, because Jakarta and Java EE, Jakarta EE had a lot of interesting specifications, like CDI that everybody uses, Java persistent, JPA, Java persistence, things like that. However, it was lacking things that are really necessary in the microservice environment, like tracing, like open API standard, like configuration, fault tolerance, things like that. So they decided, okay, we will take what we would like to have in our current standard from the original Jakarta EE and supplement it with new standards that are necessary right now. We don't want to wait. And that's how microprofile was created. However, with microprofile, currently Jakarta is already set as on the track to become real open standard, and it's in cooperation with the microprofile. However, there's one problem that happened between. This is Java this is Java Cloud Native standard, I would say. So whenever most of those those standards is good, there's two problems. The one of them is Open Tracing 3.0, and the next one is Metrics 4.0. For those, see, a lot of frameworks that were in the past fully compatible with microprofile decided to drop those two. We are talking about Wi-Fi, we are talking about Quarkus, we are talking about others. Why? This is quite interesting, because you see, Java can make its own web standards, their own cloud nativeness standards. However, most of our systems, especially in the enterprise context, are not only Java anymore. What do I mean by that? I mean that we sometimes need to cooperate with different systems. For example, written in Go, for example, written in Python, in other web systems, in other languages that I use in the modern enterprise stack. And Cloud Native, there's foundation to define standards there. It's called Cloud Native Foundation. And Cloud Native Foundation, apart of being the steward of the Kubernetes, it is also responsible for some other standards, like, for example, for telemetry and observability. So Java created an old version that was published before those standards was available, and Cloud Native Foundation created their own, called OpenTelemetry. In the Java ecosystem, there comes a problem, because microprofile has its own standards, and OpenTelemetry is a different one. So currently, the more and more popular is becoming dropping part of the microprofile just to get support for the OpenTelemetry Cloud Native Foundation standards through library called Micrometer. Anybody is using Micrometer? Okay, probably your impression is quite good, because the more and more people are starting to use it. And what is even more important, it's compatible with the rest of the ecosystem. So unfortunately, while the new standard, microprofile is very, very good standard, there's a lot of interesting parts. It's not always working with the rest of the pack. So we are waiting. Currently, we are waiting what will happen and what will be the next steps. So that was introduction of the, I would say, modern microprofile and standards connected to the observability and fault tolerance. Now it's time to discuss probably my favorite part, so runtime. Because standard frameworks are one thing, but runtime, that's where real magic happens. And if we are talking about the runtime, let's start with the first beast, Docker. Like I said, if it's Docker, it's probably cloud native, yeah? Because, whenever I see an announcement like that, run PostgreSQL the Kubernetes way, called cloud native Postgres, it started to seem a bit funny for me. However, there's a point. A lot of this, even in the previous presentation, the term cloud native was mostly used with containers. And Java, to work with containers, it needs a bit of tuning. Because as you probably already know, there is a lot of different flags that you need to set up to make your Java working properly on the given environment. For years, there was flag to use Java in the containers to be container aware. It's currently default. And there is a problem with that, this flag becoming default, in my opinion, because people forgot that it's not the only flag they should set up. Because, for example, there's a lot more that 3 years were added to the JDK that probably nobody is aware of. Who knows those flags? Who is using those flags? You know those flags. Your own friends probably don't. Because, yeah, setting flags in the JDK is quite risky thing. You need to have some experience with that. And why I'm saying that most of your friends is not using that flags, I have numbers for that. Because there is, I like industry reports, because industry reports are giving us a bit of, I would say, more extended context about how Java is really used in the production. And my favorite one is State of Java Ecosystem, created by New Relic. Why I like this one especially? Because it's not based on the declarative data, so saying, OK, we are doing that. But they have access, as the New Relic is the Java agent that is run along the virtual machine to get a telemetry. That's the standard. We are getting real data from real production. I know that probably New Relic customers are not your regular Java developers. Probably there is some kind, this is just part of the ecosystem. Still, I think the data they received through the agent are quite interesting. Because as you see, for example, max per RAM percentage, the flag usage is bigger and bigger, but still, even among the clients who is using the modern telemetry, no modern observability, there is still just 1/3 of the people who have it set up properly. Because, you know, why it cannot be run by default? The reason for that is that, unfortunately, it was the reality at the time. Java was created to work on the shared environment with other programs. So it cannot just use the max available RAM. It needs to give something to spare for the other. And in container, it's the different situation in the containers. If Java is already in the container, probably the amount of the flag should be set to 70% or something like that, because it should already use all the resources. Otherwise, it wastes the resources. So people from Microsoft, and that's one of the most interesting JEBs of this year, or my suggestion for the JEBs from this year, suggested that we should have something called ergonomic profiles. How it would work? It would be one flag to rule them all, saying that, OK, that application will be run in the container, it's run in the container, so set up all the necessary flag in a way that should be set in the containerized environment. So this is something that is already in the draft state. Currently is discussed how it should be implemented. Still, I think it's a very interesting idea, and I hope we'll see results soon. OK, so wrapping up Docker topic, it's the end of this. And for now, it's time to focus on the last and probably the most interesting part of what is happening in Java runtime in case of being cloud native. Because for me, to be cloud native, you need to do not have cold start problem. Do you know about, who heard about the cold start problem? Do you know what it is? Most of the people, wonderful. So you have context necessary for this presentation. However, I will now just read the description to set everybody on the common stage. Common way. A cold start refers to the initial state of system where the application is loaded for the first time, essentially starting from cold, because no prior activity, data caching, or active processes are in place to expedite the startup process. OK, it was quite long. However, what does it mean in practice, and why it's discussed mostly in the Java context? All Java, similar languages similar to Java. To describe that, I stolen the diagram from the Byte by Go. Does anybody knows Byte by Go? It's a very good resource for the, I would say, everything that is on the system, every information that is on the system level, or giving us information about the architecture, programming, things like that. So they are having a lot of interesting diagrams. This is one of them. Because on this diagram, we are able to see that our languages split into 3 different categories. Third one is that are interpreted. We are not interested in it at the moment. However, let's take a look on the 2 first. Because, you know, I said that I'm regularly discussing with a lot of companies, and I see the quite worrying trend. People are not just switching from Scala, people are switching from Java, or at least thinking about switching. And you know what is the direction of the current interest? Go. Yeah, exactly, Go. Why Go? I will try to describe it right now. Go is the language from the first category. So we are just compiling Go binary and then run in container, call it a day. Exactly like we would want it to have with Java. For JVM, for Java or C#, it is a bit different story, because we are not, whenever we are compiling the source code, we are not compiling it to the final version. We are compiling it to the intermediary representation and then run it on the virtual machine. So we have additional component that is both something that we need to be aware of, as well as something that we need to handle ourselves, and is adding both additional complexity and overhead. Why we need to have virtual machine? Why even virtual machine was initially created? It was created because we wanted, the original Java idea was to bring so-called run once, write once, run anywhere idea, statement. They wanted to have it working in the production. It means that we are talking about the 90s. So whenever you wanted to have a program running on the particular operating system or hardware, you needed to do it system-based system. So we needed, for example, to have multiple compilation. It's working like that even today. Virtual machines is solution for that, because you can abstract everything that is happening beneath, have runtime, common platform, and just create application once, abstracting everything that changes between the runtime environments through virtual machine. However, I have a question to you right now. When was the last time you didn't know where your application will be run in production? Because I see that pendulum currently was waved in the other direction. We are defining our production environment in code near the final program. So this whole abstraction, at least from point of write once, run anywhere, is not worth it, especially as we are saying that, for example, there are languages like Go who are taking us with force because fact that we have that original overhead. So there is a question. Let's make a tough experiment. Thought experiment, what would happen if we get rid of all those? And what we will achieve is GraalVM, is the result of this thought experiment. Once again, definition, there will be at least three next during the presentation. GraalVM is high-performance JDK distribution that compiles your Java application ahead of time into standalone binaries. Those binaries start instantly, provide peak performance with no warm-up, and use fewer resources. We have probably heard about GraalVM a lot today. So, still, I would like to put it in the proper context, describe a bit this whole holy grail of the programming. Do you recognize the movie? I warn you, there will be spoilers for it. So if somebody didn't watch the 40-year-old Indiana Jones, sorry for that. Okay. Before I will go to the GraalVM, I will start with the JVM. So JVM, like I said, is a runtime, is a platform. And on this platform, you can have multiple languages. You can have Java, that's obvious. However, you can have Kotlin, Scala, Groovy. And GraalVM is extension of the idea. Polyglottic virtual machine, one to rule them all. So idea behind GraalVM is that you will be able to, on the single JIT, single compiler, run all the possible languages. So Java, Ruby, Python, C, Scala. They are faking it a bit because some parts of the GraalVM are run on LLVM, other virtual machine project. However, they are really doing that. And fun fact of the GraalVM is that, for example, it's embedded into Oracle database to run JavaScript functions to test your data. That's my favorite combination, favorite crossover episode, for sure. Yeah. However, how GraalVM looks like in internals, let's start once again with JVM. It's obvious, however, you will see this diagram a few times during the presentation session. Let's start with just to set some pieces. You have bytecode interpreter that is used to run initial code from the Java application. This bytecode after it becomes hot. So virtual machine will be able to learn how it's really used in the production, will be taken by the just-in-time compiler to optimize it in the best way. So for example, whenever we are using a given method always with tool, just-in-time compilers know that and can create more optimal code that it's possible while using just the static compiler. And this compiled code is then used in the production. GraalVM has quite similar pieces, because the basis of the GraalVM is very thin layer of the virtual machine called substrate VM, and apart on this, there is run so-called GraalVM just-in-time compiler. This just-in-time compiler is quite interesting because its goal is to be able to run not only Java code, but also code for any other language. Any other language that can be described using framework called Truffle. Truffle is framework of writing interpreters for programming languages. So we have one GraalVM compiler that can be, I can say, swapped during production. So you can use different multiple languages in the single runtime. You have seen that on the presentation that was starting it today. So GraalVM is quite interesting solution. So what the problem we had with our cloud environment? Because if we have Kubernetes, which itself is some kind of abstraction layer, probably we don't need another abstraction layer. That's why it's worth to have something smaller. So GraalVM is very good idea for that. Because as our GraalVM is component external to virtual machine, we can use it ahead of time. Ahead of time, so compile it in the way that I was learning what compiling means when I was trying my first C application. So creating source code to binary without any intermediary representation. GraalVM for years was project that have quite intervened connection with the JDK. Currently, its community edition is being bring to the JDK itself through project Galahad. And I love the name because you see, any fans of Arturian myths there? Exactly. It's exactly that. It's the knight who bring the Holy Grail and restore it. So I think it's the best suited name for that. There is also Enterprise Edition, or rather was Enterprise Edition of the GraalVM. It was switched to the new licensing model. It's currently called GraalVM, Oracle GraalVM. And it is distributed for free. However, ask your lawyer before using it in production, because it's something that is free for many use cases, but please check yours before using, because there are a few caveats. During the EclipseCon, because I was speaking on EclipseCon this week, I finally found the lawyer who agreed with me that will help me to cope the rough edges of this license. However, like we said, if the Holy Grails were so holy, we probably wouldn't need anything more. What are the problems with the GraalVM? Not problem, just trade-offs and engineering decision maybe. GraalVM, JVM, our standard diagram here, has some more components. One of them is class path. And class path is used to add dynamic properties to Java. So what it means in practice, you don't need to have each of the class available when building application. You can add them later through the external source of classes, class path. It's not possible in GraalVM because GraalVM is running under so-called closed word assumption. Everything that will be necessary in production needs to be in the final package. That means that all those dynamic features of Java, like class loader, load class, used, for example, for drivers, method handle, proxy, or reflection, it has high time running with the GraalVM because GraalVM, while building its static images, they are trying to get rid of overhead of having all classes by just removing everything that don't have direct connection to the direct reference in the source code. So reflection is problematic. Of course, GraalVM has some solutions for that. First of them is so-called tracing agent. So something that can be run, it's allowed to run GraalVM application in the JDK mode and just check what classes are really used during production and create such a live list. The other interesting approach is having the so-called GraalVM reachability metadata repository. Publicly available database of all the classes necessary for a particular version of the library. So this is something a bit similar to what TypeScript did with their types. Those solutions are working, and this is not the blocker for project, because right now Spring can be run using GraalVM, and Spring is heavily based on the reflection. So it's not something that cannot be done. It's just additional problem, and probably not worth for each of the application. Okay, so if GraalVM is not the holy grail, sorry for that, there are some other projects in the JVM that can be used in our advantage when deploying application to cloud. The next one is AppCDS. And AppCDS is a way to improve startup and footprint, extend the existing class data sharing feature to allow application classes to be placed in the shared archive. And okay, it probably needs the further explanation, because once again, we have our JVM. Our JVM has class path, and building of class path is slow. It's slow because class path can be multi-layered. You need to just get all the classes, especially for the more complex application. So there is an idea. If we are able to get our class path compiled once, created, maybe not compiled, created, built once, maybe we can preserve it for the other usages. Because, between one deployment and another deployment, most of the time, our application do not change. Especially do not change in an environment when we are simply doing autoscaling. So, class data sharing is the original idea that came from Java 1.5, probably, something like that. And all the classes that were standard library of the JDK and were put off class path were just put in the common archive, and those, rather than building those archives each time when we are starting JVM, we can just simply reload it for drive. Already built, already prepared to be served, already compiled. AppCDS that came with Java 11 is extension of that idea. Currently, we are able to use also our own classes in the class data sharing archive. It was especially popular around the Java JDK 11 as a solution for coping with a cold start in the serverless environment. So making our JVM very fast to start, at least faster to start. So, as you see, caching. It's just standard caching. Caching is a resolution for everything. So, if we are able to cache if we are able to cache class path, maybe we can cache something more. So, our next project is called Project CRaC. And I know what you already have in your head when I'm saying Project CRaC, but it's not that. The Project CRaC is Project Coordinated Restore at Checkpoint. And what do I mean by that? The CRaC project researches coordination of Java programs with mechanisms to checkpoint a Java instance while it is executing. Restoring from the image could be a solution to some of the problems with the startup and warm-up times. I'm reading it aloud because, once again, startup, warm-up. Each of those definitions is quite similar. I think that most of the times I would just change them between each other. You wouldn't catch the difference. So yet another idea to cope with the Java startup. How it works in the practice. Once again, our diagram. We have bytecode interpreter, we have just-in-time compiler, we have compiled code. Compiled code, the just-in-time compiler is slow. It's making our application faster than we would be able to achieve ahead of time. However, it needs some information from production just to be able to do all those implementation. All those optimization. So, if we already did this, compile this code, it's already done there. Maybe we can cache it. Do I have any gamers in the room? People who play games? Okay, there are some. Any retro gamers? Any emulator users? Oh, you can, we are friends there, you can say. Yeah. So emulator users. Emulator, for those who don't know, emulator is quite clever machine because it allows us to simulate some system from the past. For example, old Nintendo console. And it's using feature called save state. How save state works in practice? You know, when we have modern games that are using, for example, 16 GB of RAM, probably saving the state of the game at the given point of time is not worth it. It's not worth to just dumping all the memory to the hard drive. It would just use too much space. However, for the older games, like for the example from 16-bit console when there was 1 megabyte of RAM, maybe it's not worth to do any surgical looking for the minimal set of parameters that is needed to restore worth. Maybe we can simply dump the whole memory on the drive and restore that memory when necessary. And that's how emulators are working, and that's how Project CRaC is working. Because Project CRaC is using something called CRaC. This is one of the Linux projects. It stands for Checkpoint and Restore in User Space. And idea behind it is like that if we are able to just create our compiled code once, we can put it on the hard drive. And when we'll be starting next application, this whole memory, because it's not just compiled code, maybe there is some data set that is read for the model, because Java is also getting popularity in the machine learning space. Maybe there's some other setup. We are able to just store it. And when we have another application, another instance, we'll be able to restore it once again. And this is something that is already implemented in few places in our ecosystem. For example, last year during re:Invent conference, so yearly conference from Amazon, the new feature, Lambda Snapstart, was presented. And that feature brings support for CRaC. It means that whenever, we can just set one YAML file, one YAML property, and whenever we do that, our Lambda function will just, at the end of initialization step, save our snapshot. And when new function will be started, we can simply restore it. This way, we are getting rid of the cold start, and they have pretty interesting numbers. What is the problem with that approach? Because it has one very interesting. Anybody has an idea what can go wrong with that? Connections. Yeah, connection is one thing. However, Project CRaC is coping with connection because we have auto-closable. So this is something that is expected. Randomness. Because randomness is generated at the start of the virtual machine. So if we are restoring the whole memory and whole compiled code, we are fighting with the randomness. Yeah. And now, Amazon, in their Corretto, they implemented special implementation of secure random just to cope with that problem and be compatible with CRaC. However, standard random will not. So if there will be any library that will be based on the standard Java randomness, it will be behave in the predictable way. Still, for many applications, it's worth it. There is Project CRaC is not only implementation of this idea. There is because this Project CRaC is a project that is driven mostly by people from Azure, but not only, but mostly by Azure. Meanwhile, people from IBM in Open Liberty created Instant On that is also using CRaC and based on the quite similar idea. Okay, wrapping everything up together. As you have seen, there were multiple puzzles during that presentation. And people in the GraalVM space also get that insight that probably we have multiple projects that are doing exactly the same or are trying to solve the same problem, but in a different way. Maybe we'll create some kind of the common abstraction that will serve all of them. And that abstraction is called Project Leyden. The primary goal of Project Leyden is to improve the startup time, time to peak performance, and footprint of Java programs. What does it mean in practice? Because it's quite vague description. For years, because it's quite an old project, it wasn't that well defined. However, last year, Mark Reinhold, so chief architect of Java, published paper selectively shifting and constrained computation. The title is not saying much as well. I think it was chosen just for nobody to read it accidentally, because who is taking paper like that? Still, it's very interesting, because shifting and constraining computation, it's a, I would say, academic way of everything we describe it today. And how Project Leyden will look in practice. Project Leyden splits our whole run of the Java program into different places. In different phases. The first one is compile time. Then we have class data sharing generation time. Then we have link time. And finally, runtime time. And each of those processes described today can be run in the particular steps. Because the major insight of the project Leyden is that there is no one way to run the Java application. Each of the program can have its own. Each of the workload can have its own. So probably we shouldn't think about the creation one-fits-all environment. We should rather create the options to do your own pipeline. And this is exactly how Project Leyden looks like, because there are applications, for example, that need to have peak performance from the start, like serverless. Because serverless applications are living for a second, so no time for warm-up. So possibly we can just use ahead of time compilation. Ahead of time compilation is achieving 80 in the GraalVM C is achieving around 80% of what is possible with JIT. For most applications, it will be fine. So let's just compile it and have something that works with a small latency. However, if we are using and deploying standard Java application that will run for hours, probably we can do this warm-up. So this code can be just transferred to the interpreted bytecode, and then used standard weight that was for all those years using JIT, achieving the peak performance after a short time. As you see, both of those workloads can be served. All those blocks we are discussing today, like ahead of time compilation, class data sharing, possibly Project CRaC, but like I said, Project CRaC is not official part of the JDK, so it's just discussion if it will become on the Project Leyden, are called condensers. And in the future, it is already hinted that GraalVM, after being introduced to the JDK, will also become one. Okay. Concluding everything, I know there was a lot. Recently, there was premiere of JDK 21. A lot was said about it. It brings a lot of very interesting features, like virtual threads, like generational VGC, things like that. Project Panama. However, I think in our community, we don't look that much as for a runtime feature. And in my opinion, they are as important for making Java cloud native, or even more, than just everything that comes to the syntax. And with that idea, I would like to thank you. If you liked what I was blabbing about, I'm the editor of the JVM weekly newsletter. When I, in the weekly form, try to describe everything that is happening in the ecosystem, especially on the low level. And meanwhile, I would like to thank you and waiting for the question. Let's see if there are some. Okay. Are there any questions? Is everything set up properly? No question. I'm not saying that Go is replacing Java. I'm saying that there's a lot of discussion like that, just for the reason that probably Go is, Java had a bad raps as well, not only Jakarta, but Java as well had bad raps. So that it's slow, that it's not fitted for the cloud, that it's using a lot of memory. Go is just presenting the community as a new cool kit, and there is a lot of discussion like that. I have this opinion a lot. I don't agree with it. I think it's not, Java is currently in the place where you, for sure, are able to use it in the as performance way as Go or even more. However, there's just a reality that people are talking about it, and I try to just I'm just trying in this presentation to explain why it's not the case anymore. GOM seems to be language of cloud native, and Go didn't have the problem of cold start. For years, there was that problem that, for example, there was a lot of publication that you shouldn't use Java in the serverless environment because it will start slow, you will have cold start and latency. You shouldn't use Java in the Kubernetes because you are not able to do auto-scaling, things like that. And people in the JVM take them to their heart and decided it is good time to cope with that, because otherwise they will just get rid of the cloud ecosystem, as well as, for example, Java is currently not that popular as it could be if you'd start doing some project earlier in the machine learning space. Mm-hmm. It is, yeah, because currently, Java is quite good serverless. It's working fine. It's just the image that was left after the beginning of the Lambda, because originally there was just Python in the Lambda server, JavaScript and Python, if I remember correctly. Then was support for more. Because currently you can just run anything in the serverless environment, because thanks to the native image, it's called native image or native. You can just put it in the Docker and run in serverless. It's working like that. Oh. Any other questions? Okay, so thank you very much.